Hello students, in this lecture we'll drive an expression for Laplacian operator, that is del square of phi, in orthogonal curvilinear coordinates. Let phi of u1, u2, u3 be a scalar point function in orthogonal curvilinear coordinate system u1, u2, u3, which is continuously differentiable. Since we know that del square of phi is equal to del dot del of phi is a scalar point function, and del of phi is a vector point function. So let us take del of phi is equal to k1 e1 unit vector plus k2 e2 unit vector plus k3 e3 unit vector, where e1, e2, e3 are the unit vectors along the orthogonal curvilinear coordinates, means along the tangential vector along the curve. So, and K1, K2, K3 are the components of the gradient of phi along these unit vectors, which are to be determined. Since R is the position of a point, as position of a point at which we have this the origin of the this curvilinear orthogonal curvilinear coordinate. Therefore, total derivative of r vector is equal to positive r vector is to u1 d1 plus positive r2 is to u2 du2 plus positive r2 is to u3. Now convert them positive this tangential vector into unit vectors. Convert these them into unit vectors with the help of the result. Um, um, ei unit vector is equal to positive r vector is to ui upon determinant of s. So let this go to h. Determinant of r is to ui is equal to hi. I is 1 to 3. Therefore, partial derivative of r equals to ui is equal to hi ei I is 1 to 3. Now substitute the value of partial derivative r is to u1 is equal to h1 u1 d1. The partial derivative r equals to u2 is equal to h2 du2 e2 into e2 into vector plus partial derivative of r vector is to u3 is equal to h3 du3 into vector e3. Because you know the total derivative of phi is can be obtained from by finding the gradient phi dot product with the total derivative of r. So substitute the value of del phi which we assumed in the equation first to be equal to k1 e1 k2 e2 k3 e3, and total derivative of r in this equation, and find their dot product. So after finding the dot, we know that E dot E1 vector is equal to 1, E2 vector dot E2 vector is equal to 1, E3 vector dot E3 vector is equal to 1, because they will behave like the unit vector ijk in the rectangle coordinates, and other product will be 0. Therefore, their product will be equal to K1 H1 D1 plus K2 K2 H2 DU2 plus K3 H3 DU3. Now this is D5. But the total derivative phi is equal to with this to u1 u2 3 will be equal to the positive phi is to u1 d1 plus positive phi is to u2 du2 plus positive phi is to u3 du3. Now left hand side of equation second third are same, therefore right hand side must be equal. After equating, we got the value of k1 h1 is equal to positive phi is to their component u same, therefore the component could this equal this therefore k1 is equal to k1 is equal to 1 upon h1 positive 5 is to u1, k2 is equal to 1 upon h2 positive 5 is to u2, and k3 is equal to 1 upon h3 positive 5 is to u3. Substitute the value of k1 k2 in equation first. We got gradient of phi is equal to 1 upon h1, partiality of phi is to e1 vector, plus 1 upon h2, partiality of phi is to u2, e2 vector, plus 1 plus c, partiality of phi is to u3. Now, Laplacian operator over an operator of stable function, that is del square phi is equal to del dot del of phi. Del of phi is this. So del dot, this is del of phi. Del of phi, we know that del of a vector is equal to 1 upon h1 this. Del of a vector is equal to 1 upon h1 h square is 3. This is positive of this one of a vector a h square is 3, and positive u2 a2 h3 h1, positive of u3 a3 h1 is 3, where a is equal to a1 e1 a2 e2 plus a3 and hi is equal to hi is equal to positive times to ui modulus this and so. Now, substitute the value. This a vector, del of a vector, this a vector is this. Vector this a1 e1 plus a2 e2 plus e2 e2. So del of a vector is equal to 1 upon h1 space 3 into partial derivative with u1 of this a into h space 3, a into h space 3 plus positive u of a2 into h3 h1 h3 h1 plus positive u3 e3 into h1 h2. Now, now after some simplification, we can write it. We can the Laplacian operator operated on this conclusion phi is equal to 1 upon h1 h2 h3 into positive u1 of h2 h3 upon h1 positive u1 plus positive u2 h3 h1 h2 positive phi is to u2 positive u3 of h1 h2 into h upon h3 upon positive u2. This is the Laplacian operator operated on its Laplacian function phi. Thank you very much.